We're going to be looking at continuing on with parabolas, sketching parabolas, in particular using the line of symmetry equation, which comes from our quadratic rule formula. X is equal to negative b on 2a. So let's have a crack at example 11. Consider the parabola given by the quadratic equation y is equal to 3x squared, take 6x plus 5. Determine the number of x-intercepts. Now, whenever you're asked the number of x-intercepts, straight away you're thinking discriminant. Okay. Now, the discriminant, if I go up before, the discriminant comes from the b squared minus 4ac part of our quadratic rule. We denote it with a triangle, and there's three possible outcomes from using the discriminant. If the discriminant is positive, greater than 0, then we can say there's two solutions, two x-intercepts. If the discriminant is equal to 0, we know that the graph will bounce on the x-axis, thus being a repeated root or one solution. And if the discriminant we know there'll be no solutions. And the reason for that is basically plugging those different values into the square root and how there's either 2, 1, or 0 possible answers, real solutions. So here we go. Determine the number of x-intercepts. So A is just saying, can you use the discriminant? So triangle, b squared minus 4ac. Now this is A, this is B, and this is C just there. So B is negative 6, 4a is 3, and C is 5. And we get negative 24. Now, as the discriminant is less than 0, we know that there's, no real solutions. What does this mean? It means there's also no x-intercepts. So if you picture this graph, it's going to be missing the x-axis. So it might be bouncing down here, here's the x-axis, or it's bouncing up here, there's the x-axis. So we've done A there, we can say there's no real solutions. B, determine the y-intercept. X is 0, plug it in, and we can see that y would have to be 5. So therefore, 0, 5. That's really nice, that one. C, using x is equal to negative b on 2a, determine the turning point. So let's find the coordinate of that turning point. The line of symmetry equation, negative b on 2a. Now, b in this case is negative 6 on 2a. And we can see that's going to be positive 6 on 6, which is 1. So there we go, we've got our x ordinate for the turning point. Let's plug that in to find our y. So y is equal to 3, 1 squared, take 6 lots of 1, plus 5, 3 minus 6 plus 5 is negative 3, and then we've got negative 3 plus 5, it's going to be 2. So therefore, we've got our coordinate 1, 2. Now you may be interested, it doesn't ask us to sketch, but we technically could now. If we had a rough sketch, we can see that there's going to be an x, the turning point is at 1, 2, just there. And we know that the y-intercept is going to be at 0, 5, so up here. And that's going to be symmetrical both sides of the line of symmetry, which is just here. So we can see that this graph is going to look something like this. And we can see how there's no x-intercepts or no real solutions to the discriminant. Okay? So what I'd like you to do now is have a go at the your turn on the right. So you can pause the video and then play it when you're ready to go. We're going to go through the answers now. So consider the parabola. Determine the number of x-intercepts. So discriminant b squared minus 4ac, b squared. Remember b is going to be negative 4, just be careful with that. Take 4, 2, 1, 16 minus 8, 8. Therefore, there is 2 real solutions as the discriminant is greater than 0. Now, another way of saying that is that there's 2x. Actually, I'll just clean this up. I'll just say 2 distinct X-Intercepts. That means they're going to be in two different locations. Next, they're after the Y-intercept. Y-intercept is really easy. C. Determine the line of symmetry. A little bit boring. It seems like it's the same answer. Got the line of symmetry of 1. Now we want to find that turning point. So that's going to be -2 plus 1. It's -1. And there's our turning point at 1, -1. Now, if we did a bit of a sketch, we can have a look at what this is going to look like. It hasn't asked us to do a sketch, but it's always interesting to see. Just to double check your answers. Okay, so 1, -1. So there's a turning point there. Line of symmetry is at x is equal to 1. 0, 1, and then the other side, that's our y-intercept we've just put in. And we do have some, we don't have the x-intercepts and all, but that's enough to sketch us this graph. And we can see there are indeed 2 real solutions, or 2 x-intercepts. So we can see that through checking our answer, we have got it correct. Well, thank you very much. I hope this video is useful as well. Yeah, and this wraps up lesson 4. Thanks.